billions of years, the universe was a silent machine, a symphony of physics, chemistry, and gravity playing to an empty theater. There were stars, there were planets, but there was no one to witness them. Until, on one unremarkable rock, orbiting an average yellow star, something impossible happened. Matter woke up. Today, we are going to tell the greatest story ever told. It is our story, the story of how dead atoms learned to love, fear, and dream. And we will ask the ultimate question. Now that life has taken control of its own destiny, what do we become next? The primordial crucible. 4.5 billion years ago, the Earth was hell. There is no other word for it. This was the Hadean Eon. The planet was a seething cauldron of magma, constantly bombarded by asteroids left over from the solar system's formation. The atmosphere was a toxic cocktail of methane, ammonia, and carbon dioxide. Surface temperatures could melt lead. If you stood there, you would vanish instantly. It seems impossible that this violent crucible could be the cradle of biology. But chaos is often a ladder. As the bombardment slowed, the Earth cooled. The steam in the atmosphere condensed and fell as relentless acid rain for millions of years, creating the first global oceans. Deep beneath these chemical seas, shielded from deadly solar radiation, the stage was set. At hydrothermal vents, blazing heat from the core met the freezing ocean. These vents were chemical factories, churning out complex minerals and organic compounds. The ingredients were all there. The kitchen was open. All it needed was a spark. The impossible spark, abiogenesis. How does dead chemistry become living biology? This is abiogenesis, the origin of life. It is perhaps the greatest unsolved mystery in science. But we have clues. We know that in the chaotic chemistry of the early oceans, basic building blocks called amino acids and nucleotides formed naturally. Lightning strikes and volcanic heat acted as catalysts. The leading theory is the RNA world. Before DNA, there was RNA, a molecule capable of both storing information and acting as an enzyme to speed up reactions. Imagine a chaotic soup where billions of molecular combinations were tested every second for millions of years. Eventually, by sheer chance, a molecule formed that could do something miraculous. It could copy itself. This was the threshold, the moment the universe began to remember. Natural selection kicked in immediately. Molecules that replicated faster or more accurately became more numerous. Eventually, these self-replicating systems became trapped inside tiny bubbles of fatty lipids, the first rudimentary cell walls. These weren't fully alive yet, not by modern standards, but they were no longer just chemistry. They were the seeds of everything to come. The long sleep, the prokaryotic reign. For the next 2 billion years, if you visited Earth, you would think it was dead. But if you looked closely at the coastal slime, you would see the rulers of the world. These were prokaryotes, simple, single-celled bacteria and archaea. They had no nucleus, no complex internal machinery. They were rugged survivalists, drifting in the oceans, harnessing chemical energy from rocks or geothermal vents. Life was microscopic, simple, and slow. Evolution seemed to have stalled. This vast stretch of time is often called the boring billion. But beneath the surface, these simple cells were mastering chemistry. They learned to live in boiling acid, in crushing pressure, and in total darkness. They terraformed the planet on a microscopic scale, refining the metabolic pathways that still power your body today. They were laying the groundwork for complexity, waiting for an energy source powerful enough to fuel a revolution. The oxygen catastrophe and the Great Merger. Around 2.4 billion years ago, a specific type of bacteria, Cyanobacteria, hacked the ultimate energy source, sunlight. They developed photosynthesis. They took sunlight, water, and carbon dioxide to create food, releasing a waste product that changed everything: oxygen. For the anaerobic life that had ruled for eons, oxygen was a deadly poison. This was the Great Oxidation Event, Earth's first mass extinction. The planet rusted. Iron dissolved in the oceans reacted with the new oxygen, turning the seas blood red before settling as rust on the seafloor. But the crisis spurred innovation. Some survivors learned to utilize this reactive oxygen to generate massive amounts of energy. Then, the most significant merger in history occurred. A large predatory cell engulfed a smaller, oxygen-breathing bacterium. But it didn't digest it. They formed a partnership. The smaller bacterium became the mitochondrion, the powerhouse of the cell. This was the birth of the eukaryote, the complex cell with a nucleus. Every animal, plant, and fungus alive today is a descendant of that ancient merger. Life now had the power to get big. The Cambrian Explosion. Life gets visible. After billions of years of microscopic simplicity, life suddenly exploded. Around 541 million years ago, in a geological blink of an eye, entirely new body plans appeared. This was the Cambrian Explosion. For the first time, life had a face. The oceans teemed with bizarre creatures, arthropods with hard exoskeletons, mollusks, and early chordates, the ancestors of vertebrates. Why the sudden change? The oxygen levels had finally risen high enough to support active, high-energy lifestyles. But it was also spurred by a new invention: predation. Before this, life was mostly passive mats of slime. Now, things were hunting other things. This triggered an evolutionary arms race. The development of eyes changed the rules of engagement instantly. Animals evolved armor, spikes, faster swimming speeds, and burrowing behaviors to escape. The gentle garden was gone. The arena had opened. Conquering the land and the great dying. For 90% of its history, life was confined to the water. The land was a barren, irradiated rock surface. But plant life, descendants of those green algae, slowly crept onto the shore, creating the first soils and shielding the surface with an ozone layer. Arthropods, insects, and spiders followed the plants. Then, about 375 million years ago, brave fish with sturdy, limb-like fins ventured onto the mud. They were the ancestors of all amphibians, reptiles, birds, and mammals. Great forests covered the continents. Giant dragonflies with 2-foot wingspans buzzed through oxygen-rich air. Life was thriving. And then, it almost ended. 252 million years ago, the Great Dying occurred. The Permian Triassic Extinction. Massive volcanic eruptions in Siberia spewed enough greenhouse gases to raise global temperatures catastrophically. The oceans acidified and lost their oxygen. 96% of all marine species vanished. Life on Earth was nearly rebooted back to zero. The reptilian reign and the mammalian opportunity. The survivors of the Great Dying found an empty world. The reptiles, specifically the archosaurs, rose to dominance, evolving into the dinosaurs. For 160 million years, they were the undisputed masters of the planet. They grew to titanic sizes, occupying every niche from apex predator to massive herbivore. During this time, our ancestors, the mammals, were relegated to the shadows. We were small, nocturnal insect eaters, trying not to get stepped on. We developed warm blood and acute hearing just to survive the night. Evolution is often dictated by blind luck. 66 million years ago, a 10-kilometer-wide asteroid slammed into Earth. The impact was apocalyptic. Dinosaurs, except for birds, were wiped out in the ensuing nuclear winter. The age of reptiles was over in a single day. The mammals crawled out of their burrows into a devastated but empty world. The crown was vacant. The rise of the thinking ape. In the dense forests of Africa, a lineage of primates began to change. As the climate dried and jungles turned to savanna, one group adapted by standing up. Bipedalism freed our hands. We weren't the fastest or strongest animals. We survived with two unique weapons: cooperation and a rapidly growing brain. We learned to control fire, turning night into day and unlocking more calories from cooked food, fueling our expensive brains. We remembered patterns, tracked seasons, and developed complex language to plan hunts. Homo sapiens appeared roughly 300,000 years ago. In just the last few millennia, we went from chipping stone tools to splitting the atom. We became the first species to occupy every habitat on Earth, and the first to escape its gravity. We are the universe becoming aware of itself, but the pressures of natural selection that built us are about to become obsolete. The near future. Directed evolution. For 4 billion years, evolution was a slow, blind game of chance, dictated by environmental pressures. That era is ending. We have entered the age of directed evolution. With technologies like CRISPR, we have the ability to edit the source code of life itself. We can potentially eliminate genetic diseases, enhance our intelligence, and extend our lifespans by centuries. We are fast approaching the singularity, the moment when biological intelligence merges with artificial intelligence. Brain-computer interfaces could allow us to connect our minds directly to the cloud, accessing all human knowledge instantly. The humans of the next century may not just be born, they may be designed. We are taking the reins of our own biology, transitioning from creatures of circumstance to the architects of our own future. The ethical challenges will be immense, but the genie is out of the bottle. The far future. Cosmic humanity. As we look deep into the future, the definition of human will blur. If we survive long enough to become a multi-planetary species, evolution will begin again. Humans living in the low gravity of Mars or the moons of Jupiter will physically diverge from Earth humans over thousands of generations. We may become dozens of different species scattered across the stars. Ultimately, biology itself might be just a stepping stone. We may shed our fragile bodies entirely, existing as digital consciousness, exploring a universe we can currently barely comprehend. Life began as a fragile chemical ripple in a hostile ocean. It has endured ice ages, volcanism, and asteroid impacts. It will not stop here. The story of life is far from over. The most exciting chapters have yet to be written, and the pen is now in our hands.